Okay, today we're going to focus on 4.5. That is translating word problems. We are also going to be going back to a little bit of 4.1 to do the basics of word problems. All right, so take a minute, pause the recording, and write down your objectives. Okay, now I'm going to kind of be bouncing around. Let's go back here. I want you to take a minute and make sure that you have all these symbols. Take a minute to do that. Pause the recording. All right. Okay, good. I've already inserted it here. All right, so next paper, the next slide I want you to take notes on so that you have something for your notes is, let's take a look at this. This is, let's look, this is less than, here's an example, and here is a graph. So if anybody wants to take notes on that, keep that in your journal. Here is a greater than, is greater than is the wording, x, y is greater than -3. I kind of find these a little bit more difficult to follow, but when you're in a pinch, you want this in your notebook. Okay. And so remembering that when we see is less than or equal to, it's implying the inequality result. So pause the recording and take that. Take those notes. All right. So let's get back into our translating. Now we're going a little bit back to section 1, which write an inequality to represent each sentence. So when we see a number, before when we would have x more than, I'm going to compare these two, 5, okay? The difference is this has is more than. When you just see more than, it means the terms flip places, and this is a plus sign. But when you see a number x and they say is more than, that signifies the greater than sign, 18. And that's because of this is, which signifies the result. Usually that's our equal sign, is more than 18. Okay, pause the recording. Try number 2. All right, let's check it. Number y is less than or equal to, have to put the equal sign there, -12. Pause the recording and try the next 2 on your own. All right, let's try it. Twice a number x is less than, there's my inequality, 5. And the last one, 8 more than, there's no is there. 8 more than twice a number p. How do I write that? 8 more than twice a number p. This is 2p. Here's the 8. This says more than, but what do we have to do? We have to switch our, remember one's coming over here, the other's coming over here. We have to switch the terms. 2p. 2p plus 8 is less than or equal to 40. Okay, pause the recording if you need to keep taking notes. All right, so here's where they get tricky. Now, x is at least 5. When you see is at least, I always think of money in my pocket. I have at least $5. That means I could have 5, I could have 6. They say, can you go to the movies? Well, let me see what I got. I have at least $5. 1, 2, 3, 4. That means there's more in there. So that means greater than. This is what gets tricky. Is at least means X is greater than or equal to 5. I need you to write this down. Okay, Y is at most $10. That means Y is less than or equal to. It could equal 10, but at most. P is no more than 6. So P has to be less than or equal to 6. And N is no less than 8. So we do N is greater than or equal to 8. Pause the recording if you are still writing. Okay, now we're going to use these. Why don't you pause it and see what you can do first? Okay, now let's check our work. Twice a number X plus 4 is at least, that means it can be more than 10, so it would be greater than or equal to 10. Okay, let's try the next one. Hopefully you got this. 5 less than 3 times y. 5 less than 3 times y. There's no is there. So that means this is one of those where this less than means minus. This is a 3y. This is a 5, but because it says than, less than, we have to crisscross the terms. 3y minus 5. Okay? Is at most. So that means it has to be less than or equal to 19. Okay? Twice the sum of x and 9. Twice the sum. Okay? If I have a sum, I have to send it to the and. There's my plus sign, x and 9. How do I show twice that? It would be 2 times the parenthesis of x plus 9. Is no more than. Has to be less than or equal to 35. And last, 15 is less than. So I'm doing this, is less than. This is the inequality sign. 6 times the difference of P and 7. Send the difference to the and sign. So 6 times the difference would be P minus 7. You can't just do 6P because it's 6 times the difference, and the difference is P minus 7. Wow, here we go. Oh, you bringing me? Okay, so we're building up. So again, our phrases that get 5 more than x is x plus 5, but then when it has the is more than x, it's the inequality sign. 5 is more than x. It would be 5 is greater than x, or x is less than, good. Or we could write it x is less than 5. X less 8 is x minus 8. X less than 8 means 8 minus x. When you have than, you flip-flop the terms, right? There's no is, so it's not an inequality. Thank you. Will you shut that door, because Kai doesn't like to hear me. Sorry, guys. And then we've got x is less than 8, which signifies to use the inequality. Okay, so there we go. Please, I'm going to let you pause it and take notes. Okay, let's move on. Oh, x is at least 8. That means x is less than or equal, no, is greater than or equal to 8. Because when it says at most, it would be, which I think then we should add right here. here. X is at most, I guess it doesn't matter where we write it, but it doesn't really go. It should be X is at most 8 would be X is less than or equal to 8. Okay, X is at most. Okay, here we go. Let's try it. Write an inequality, represent each sentence, and solve. Okay, so we're writing the inequality, not the equation, basically what we were doing before, and then we have to solve it. So there's 2 actions here, 2 verbs. So 3 more than X, okay? I've got this more than right here. So right here, this is a 3, this is an X. We're going to have to crisscross that. So it's 3, and this becomes the X, and more than is plus. Is less than, there's my inequality, is less than 10 less X. There's no than there, so we just write it straight. Okay, so there is our inequality. Okay, now I'm going to solve it. We have to subtract 3 from both sides. So I like to get my x's together first, right? Let's go, so we can keep our x's positive. And then I get 2x plus 3 is less than 10. Subtract the 3, and we end up with 2x is less than 7. Divide by 2, and x is less than 7 over 2. We've solved it. It doesn't say to graph, so I'm not going to graph. Okay. Let's hope that Miss Yamasaki got it right. Now the glory of algebra is we don't have to switch it to a mixed number. Now pause the recording and you try the next one on your own. Okay, let's try it. 4 less than twice p. See, that is, so I'm going to just stop there. 4, oops. So 4 less than twice p. So that sounds like I have to crisscross 2p, 4, and it's less than. Then we have is at least. That means I have at least $10. I could have 10, 11, so it's greater than or equal to 20 less than p. 20 less than p. So again, we're going to have to crisscross and put the 20 here and the p here. So it's p minus 20. Maybe you want to see it in PowerPoint because it looks cleaner. So we're going to subtract our p, get the p's all together. I always go for the p's so I can keep them positive, so I don't have to divide a negative and then end up having to flip the inequality. So p is greater than negative 16. Oops. And there we go. Okay, so we're getting bigger with our word problems. Mark has $13 more than Bill. If together they have at most $85, what is the most money that Bill could have? So let's call Mark, we can do it with one variable or 2. Let's see how we're doing it on our... Okay, we're going to solve this with one variable because I'm forgetting this is in chapter 4. And we haven't learned how to solve with x and y. We've only learned with 1. So we can call Mark, let's just name their money, Mark and Bill. And we'll use, who do they give less information on? If we do one variable, Mark has 13 more than Bill. Bill has less information, so we'll call him x, and we'll call Mark x plus 13, more than. Remember, we're translating Mark 13 more than Bill, so it would be is x, that's 13. We have to flip the inequality around. If together they have at most, that means Mark and Bill together, at most, that means they have to have less than or equal to 85. And then we set it up. X plus 13 plus x is less than or 85. I'm going to go back to the PowerPoint because it's cleaner. Okay. And now we're going to add them both up. 2x plus 13. We can subtract 13 from both sides. And then we're going to divide both sides by 2. And x is less than or equal to 36. Now, if x is 36, then remember that's Bill's money. And now we've got to figure out Mark's money. So 36 plus 13 is 49. Now we have to see, add that up and say, do they have 85 or less? So 15, carry the 1, it's 85. Check. We do have enough. That works. All right. Sum of consecutive integers. Yay, Ms. Yamasaki. Okay, so the sum of the consecutive integers is less than 60. So we've been doing these, okay? We've been doing these. So if they're talking about 3 consecutive integers, that means 3 in a row. They didn't say odd, they didn't say even. So what are we going to call the first one? Call it the first int is x. What are we going to call the second integer? They say 3 consecutive. That means I have to add 1 more to it on the number line. And then the third integer. Now, how am I getting this? Remember, we don't know. This is a number line. Now, only you can see 1, 2, 3, 4, 5, 6. But really, people can't see this. So if we don't know what this is, we can say our first integer is here. 3 consecutive means they're in a row. Here's the second, here's the third. So what would I do to the x? I add 1, I add 2 to the original x. That's how we get those. And so the third one would be x plus 3. And if they're asking us to do a sum, that means to add them. X plus 1, right, plus x plus 3 is less than 60. I can combine my like terms. I get 3x plus 3 is less than 60. Subtracting 3. 3x is less than 57. Divide both sides by 3. 3 into 57. Now this is going to be important. It goes once. Goes 9 times. So x has to be less than 19. Okay, the sum of 3 consecutive integers is less than 60. What is the greatest possible pair for each integer? Well, is x allowed to be 19? Because it says x has to be less than 19. So since it can't be 19, we go to the closest integer. An integer is a negative or positive whole number. So that means this is 18. This would have to be 19. Oh, this should be a 2, right? And this should be 20. Now let's see if Ms. Yamasaki's right. Okay, we got there. But we have 18, 19, 20. And the way you check is, remember their sum has to be less than 20. So here we are, 57, and it works. Okay, so consecutive integer problems with inequalities. All right, Heather, this is a typical question on a standardized test. Heather received grades of 80, 75, and 86 on 3 algebra tests. What must her grade be if on the next test, if her average for the 4 tests is to be at least 82? So You guys know how to do an average. You just add up all the tests and then divide by the number of tests. So I pulled this from the book, so I don't think there's really any PowerPoint to it. Okay, so really we'll say, the first test was an 80, the second was a 75, the third was an 86, and then what must her grade be on the next test? For the 4 is to be at least an 82. The fourth, we don't know it. We'll call it X. So how we do an average is we have to add them all together. 80 plus 75 plus 86 plus the fourth test. We have to divide it by, plus the fourth test, we'll call it X. And we have to divide that by 1, 2, 3, 4 tests. Now all of that has to be greater than or equal to, because if it's less than, it won't give her an 82. An 82. There we go. We add it up. I should have brought my calculator here. I'm going 80 plus 75 plus 86 plus, I'm just not going to do that last one, plus. Okay, that's 241 plus X all over 4 is greater than or equal to 82. So we've got to get that 4 out of the denominator, and I'm going to multiply both sides by 4. That cancels, so I'm left with 241 plus X is greater than or equal to, oh dear, 82 times 4 is 328. So we're subtracting 241, and we get X is greater than or equal to 87. There we go. So on her fourth test, she needs to get 87% or greater. X has to be greater than or equal to. All right. There we go. Oops. These are 4 consecutive odd whole numbers whose sum is less than 38. Okay, pause the recording and try this one on your own. All right, let's check our work. So if it's 4 consecutive odd, we'll say X is the first odd. Let's do it this way. And then I'll say the second is going to be X plus 2. Remember, with our odd, the third will be X plus 4, and the fourth will be X plus 6. So the final, find all sets of 4 consecutive odd whole numbers. This is a good one, okay? All sets whose sum is less than 38. So you need to know the definition of a whole number, because whole numbers, they're giving us a boundary here. They're saying all sets, 4 numbers in a row that add up to less than 38. Okay, and whole numbers means they start at 0, because that's where the whole numbers start. 0, 1, 2, 3, 0 is part of the wholes. So we have to add those up, and I get X plus X plus 4 plus X plus 6. It has whose sum is less than 38. So we get 1, 2, 3, 4x, 2, 6, 12 plus 12. I added up all my like terms. Is less than 38, so I'm subtracting 12. Okay, and then I'm going to get 4x is less than 8 minus 2 is 6. Minus 1 is 2. divided by 4, divided by 4, and x. 26 divided by 4, pay close attention, is less than 6.5. So we're looking at odd whole numbers that are less than, you've got to make sense of this. So what's the closest odd whole number that is less than 6.5? Well, 6 is the closest integer, but they need an odd number, not a decimal value. So I'm going to jump down to 5 is the closest odd whole number. And 5 plus 2 would be 7. And 5 plus 4 would be 9. And 5 plus 6 would be 11. So now we have to check, does that all add up to less? 11 and 9, that's 20. And that's 32. Check that works. Okay? This adds up to 32. Right? It's 20, 32. Okay, but they asked for all sets. So the highest x, we went to the closest odd underneath there is 5, but there's another one. How about 3? So what if it's 3? That would make this one 5, this one 7, this one 9. So that works, right? Let's do this with 32. Because that's 16 and 8, that's 24. That works. What if, find all sets of 4 consecutive odd whole numbers. Let's see, 3, 1, 0. I only have 2 odd sets. So these are the 2 sets. 5, 7, 9, 11. And also, I guess you should have put a colon. And then the other set is 3, 5, 7, and 9. And then close your brace. Okay? Pause the recording if you're still stuck. Okay, let's move on. Okay, a water tank contains 500 gallons. I believe this was actually part of the homework. Some of these problems. Let's see. Close. Oh yeah, I may have even pulled out. It's a little bit different. Okay. No, it's not. Okay. So a water tank contains 500 gallons of water and begins leaking at a rate of 4 gallons per minute. Because the tank must be repaired from the inside, it can retain at most 60 gallons of water. So how long must the water repairman wait to fix the tank? Okay, so a water tank contains 500 gallons of water and begins leaking at a rate of 400 gallons per minute. Because the tank must be repaired from the inside, it can retain at most 60 gallons of water. How long must the repairman wait to fix the tank? Okay, so first let's figure out, I'm seeing right here is the equation. 500 gallons of water, that's the starting amount, and begins leaking at a rate of 4 gallons per minute. So what is unknown is how long, right? So we're going to call X minutes, right? 4 gallons per minute, we don't know what that was. So if that's the case, my starting amount is 500, and then I am losing 4 gallons per minute, right? Because the tank must be repaired from the inside, it can retain at most. So this has to be less than or equal to or greater than or equal to. This side has to be greater than or equal to 60 at most. No, it has to be less than or equal to. So the water in the tank, we have to wait for it to get down to less than or equal to 60 because they can't work on it if it's more than. So this side has to be less than. So when they say at most, it's really tricky, isn't it? You have to make sense of that. And so there's our equation. Even I really have to make sense of it. So now I'm doing minus 500, minus 500. I think this is going to be a pretty number. 4x, oh my gosh, 560. So 4 goes into 56. I know that from, and it's a negative. Nope, it's not 560. It's 500 minus 60, so it'd be 540, right? So I'm dividing by -4, I'm dividing by -4. Now I don't know, x has to be less than or equal to 540 divided by 4 is 135. So what they have to wait, remember x stands for minutes, so they have to wait 135 minutes. And guys, on your test, you're not writing the units and putting that into sentence form or like word form. You have to write the units and take it back to the story. So x has to be at least 135 minutes. So if you want to convert that to hours, you are welcome to. Oh, I did that right. Whoa! What did I do wrong? It was 440. That's what I did wrong. Let's see. Let's go back. I did that wrong. Okay. Look what I did. 500 minus 60 is... There we go. Let's do this. I did a couple things wrong. Sorry. It's morning. I'm at my worst right now. But this will help me for later on in the day when I'm explaining. This should have been 5. This should have been 440. There. That's much cleaner. And now when I divide by that negative... Yamasaki forgot what I get you guys on. I forgot I divided by a negative. That means it has to be, and so this is going to be 110. So the minutes has to be greater than or equal to 110. 110 minutes. Wow, Yamasaki. At least 110 minutes. Okay. I think we did this one already. I think we're good for now. These are just more of some of the homework problems. And so I think that's about it. Okay, guys. Remember, I have tutoring at 4 to 5 on Friday. Hope to see you then.